What if the entire universe was made not of particles, but of tiny vibrating strings? Sounds like sci-fi, right? But this is the heart of one of the most ambitious theories in physics, string theory. For most of modern science, we believed that atoms were the basic units of matter. Then we found out atoms are made of protons, neutrons, and electrons. Then we zoomed in further and found quarks, leptons. But string theory says even those aren't the end of the line. Instead, it proposes that every fundamental particle is actually the same thing, a tiny one-dimensional loop of energy, a string. And the reason particles seem different? It all depends on how the string vibrates. A slow vibration might become a graviton, which carries gravity. A different vibration becomes an electron. Another, a photon, the particle of light. Different vibrations, different particles. Same string. It's like a cosmic violin, same instrument, infinite songs. So why do physicists even want this theory? Because there's a huge problem in science. Einstein's theory of gravity, general relativity, is brilliant. Quantum mechanics, which governs atoms and particles, also brilliant, but the two don't agree. Try to combine them and the math just explodes. You get infinities, nonsense, black holes become mathematical nightmares. String theory might be the bridge, because unlike point particles, strings don't break the math. They smooth out the infinities. They let gravity and quantum mechanics coexist. So how does it actually work? In string theory, particles are tiny loops or segments of string. But they don't just float around randomly. They exist in specific ways depending on tension, mode, and boundary conditions. There are two main types: open strings with loose ends and closed strings which form loops. Open strings can attach to surfaces called branes, short for membranes, which can be as small as a particle or as large as a universe. Closed strings are especially important because one of their vibrational modes naturally produces a graviton, the theoretical particle of gravity. And these strings don't just vibrate in 3 dimensions. For the math to work, they have to vibrate in 10 dimensions, 9 of space and 1 of time. Some versions of the theory require supersymmetry, a kind of symmetry where every particle has a partner. This helps eliminate mathematical contradictions, but it also predicts particles we haven't discovered yet. And when you look at the math, you don't get one neat version. You get 5 different string theories. But in the 1990s, physicists found something strange. They were all connected, like different sides of a bigger, deeper theory, M theory. So, is string theory the ultimate theory of the universe? Maybe. It hasn't been proven yet. Some scientists love it, others say it's beautiful math with no evidence. But if it is true, then everything you see, your body, the earth, light, gravity, it's all music that played on vibrating strings.